Morning to all. I am Mynavathi, Assistant Professor, Department of Mathematics, KSR College of Arts and Science for Women. My paper name is Differential Geometry. We will discuss Unit 4 and 5 topics. The following topics are covered in Unit 4 and 5. Non-inelastic properties of a surface, the second fundamental form of principal curvature, lines of curvature, developable associated with the space curves and with curves on a surface, minimal surfaces, ruled surfaces. The following definitions are basic in Unit 4. Here are some non-inelastic properties of a surface. Developable surface, a smooth surface with a zero Gaussian curvature that can be turned into a plane without distortion. Developable surfaces are a special type of ruled surfaces. Lines of a curvature, a non-inelastic properties of a surfaces. Principal curvature, a non-inelastic property of a surface. The second fundamental form and the first fundamental form define the principal curvature of a surface. Inelastic properties of a surface are properties that do not depend on how the surface is immersed in the surrounding space. For example, the length of a curve on a sheet of a paper is an inelastic property because it does not change when the sheet is folded. However, the distance between 2 points on the sheet is space is not inelastic. Developable surface are a special type of ruled surface that can be associated with the space curves and the curves on a surface and are related to minimal surface. What is meant by developable surface? These surfaces are smooth and have a Gaussian curvature of zeros, meaning they can be flattened onto a plane without a destroy. They can be formed by bending thin flat sheets of materials. Developable surfaces are used in computer graphics, computer-aided designs, computational and manufacturing architecture. Space curve. A developable surface can be constructed from a space curve into two ways, the tangent developable and the rectifiable developable. Minimal surface. For example of minimal surfaces include surface, cosets, minimal surface, and etc. Ruled surface. A developable surface is a smooth surface whose Gaussian curvature vanishes everywhere. A ruled surface is a surface where for each point that must be a line passing through the point lie on a surface. Isometric correspondence. In the content isometric correspondence, inelastic properties of a surface are properties that are not changed by bending deformation that preserve length. These properties are independent of the surface's relationship to the space it's embedded in. Here are some examples of inelastic properties: distance, angle, area, total curvature, geometric curvature, and geostix. Some properties that are not preserved by isometric mapping include mean curvature, normal curvature, geometric torsion, curvature, and torsion of a curve on a surface, line of a curvature, asymptotic lines. Inelastic surface properties are not affected by the choice of coordinate system, the position of the viewer relative to the surface, and the particular permutations of the surface. Next, we will discuss basic definition of Unit 5. Before we discuss the definition, the following topics are included: differential geometry of surface, compact surface whose points are Hilbert's lemma, compact surface of constant curvature, complete surface and their characterization, Hilbert's theorem, conjugate points on a geostix. Differential geometry on surface. Differential geometry is a mathematical discipline that studies the geometry of smooth shapes and smooth, otherwise known as a smooth manifold. It uses the techniques of differential calculus, integral calculus, linear algebra, and multilinear algebra. Hilbert's lemma. Hilbert's lemma was proposed at the end of 19th century by the mathematician David Hilbert. The lemma describes a property of the principal curvature of surface. It may be used to prove Liebman's theorem that a compact surface with a constant Gaussian curvature must be a sphere. Compact surface of a constant curvature. A compact surface of a constant curvature is a surface with a constant curvature at every point, and for every two-dimensional tangent plane at the point. Complete surface and their characterization. Characteristic classes are global invariants that measure the deviation of a local product structure from a global product structure. There are one of the unifying geometric concept is algebraic topology, differential geometry and algebraic geometry. What is meant by Hilbert's theorem? N differential geometry Hilbert's theorem is a key result that states that no complete regular surface of a constant negative Gaussian curvature can be immersed in. It was established in 1901. In geometric differential geometry, conjugate points, also known as a focal points, are the points that can be almost joined by a one-parameter family of geosticks. They indicate when geosticks are not length minimizing conjugate points, or points on a geostick where nearby geostick intersect. Definitions. 2 points are a geosticks are conjugate if there is a non-trivial Jacobi field that vanishes at both points. Thank you.